In this video, we are going to create a grid visualization using a custom shader, and we are going to place it on top of our plane where we want to be placing our objects. To create our grid visualization, we need to use a custom shader, and to do that we need to import the shader graph package. So go to the top menu window and select the package manager. Here in the top left corner we are going to select the Unity registry from a list, and in the top right corner in the search box we are going to type shader. And now you should see the shader graph package. Make sure that you download it into your project. When you have this package installed, we need to also download the sample package. So here in the shader graph description we have those samples, and this contains procedural patterns. Those include a rectangular grid and a hex grid, so make sure that you import this into your own project. When you are done, in the project tab you are going to find in the assets samples folder, which contains your sub-shaders that we have imported as samples. Before we explore those samples, we are going to create a new shader graph. So I'm going to select my shaders folder, right click, create, select shader graph. I'm using URP pipeline, so I'm going to select the unlit shader graph. I'm going to call it grid, rectangular, transparent. And I'm going to open this shader up. Okay, here is my graph. Here in the shader graph window, press spacebar and either search for grid. And if you don't find anything, we will need to go to samples and open those folders until you reach the sub-shaders. We're going to drag the grid sub-shader into our graph, and I'm going to maximize our shader graph. And as you can see, here is our grid node. So we can modify the size, and we need to keep it around 1, but basically we are controlling the size of the cells. I'm going to set it to 0.95 for now. The next parameter that we have is the tiling. We can set it to 4 by 4. Basically, we are modifying the number of cells shown or outputted by our grid node. And we can modify the offset, so this allows us to adjust the position of those grid lines and the cells if we need to. Now, since we want to grab the edges or the lines of our grid rather than the cells, we are going to drag the output of the grid to 1 minus node. So now you can see that those white lines are representing what will be visible, and the black spaces, so the cells, will be transparent. Right now we need to enable transparency in our shader, so go to the graph inspector. If you don't see it, just press in the top right corner graph inspector and the blackboard. We're going to go to the settings, we're going to select the surface type, we're going to select transparent. And now in the fragment shader we should see not only the base color but also the alpha value. We're going to drag the output of the 1 minus node to the base color and to the alpha value. And in the main preview, you can right click and select the quad, and you will see that we are now outputting a grid that is 4 by 4. Let's save our shader. Click Save Asset in the top left corner. I'm going to unmaximize the shader, and I'm going to go to my shaders folder, right click on the shader graph that I have created, create, and I'm going to select material. Okay, I'm going to select the scene view, and I'm going to create in the hierarchy, select a 3D object and create a plane. Since there is a bit of Z fighting, we are going to select the transform of this plane, make sure that it is set on 0, 0, 0, and on the y-axis we are going to raise it by 0.015. So it is on top of our grass plane, and I'm going to drag our shader graph material that we have created on this plane. And as you can see, we have our grid visualization, our grid overlay on top of our grass plane. Now the problem with this is that if I select the transform of the plane and scale it on X, we are going to be stretching the cells instead of adding more cells to our grid. So that's what we want to achieve. Also, I want to point out that if we select our plane and press Shift H, we're going to go to the isolation mode for this plane. If I now go to the scene view and select the display mode and select the wireframe, we're going to see that actually our plane is represented by 10 Unity units by 10 Unity units. So this is the default scale. Okay, let's reset the shading mode to be shaded, and let's press Shift H to go out of the isolation mode for the plane, and let's go back to our shader. To be able to use our scale properly and to add more cells when we scale our plane, we will need to go to the blackboard, and here we are going to add a new vector2 property using this plus icon. Let's call it default scale, and we are going to set it using the graph inspector. Using the node settings, we are going to set the default value to be 10 by 10, since this is the size of our plane in Unity units. Next thing that we want to do is add another variable of type color, and we are going to call it, well, we can leave it as a color. This will be the color of our grid. Let's set the default color to be white with full alpha, although it doesn't really matter. Now, to be able to modify the size of our grid, we are going to add another vector2 size, and we are going to leave it for now at 1 by 1. So let's set the default value to 1 by 1, and we are going to be able to modify the size of the cells of the grid. Next, we need to add another parameter of type float, and we are going to call it thickness. And this will be the thickness of our grid lines. We are going to select the mode to be a slider, and we are going to set the min value to be 0.01, and we are going to set the max value to be 0.05. And let's set the default value to be 0.05. Okay, so this will allow us to set the thickness of the grid lines. So let's drag the graph inspector away, and we are going to add a new node. So press spacebar, and we are going to type object. Because we need to access the scale of this object, we are going to drag it to the split node, because we need to access only the x and the z value, so r and b. So we are going to drag the r value, so x, to the vector to x value, and we are going to drag the b value, so the z scale, to the y of this vector 2. Let's drag it a bit further. So now we have our scale of the object. We are going to drag it to a multiply node, and I have already explained that the default scale of the object or default size is 10 by 10. So we're going to multiply the output of the scale by the default size of our plane. So this will be the 10 by 10 value. Now we can use the output of this multiply node directly onto the grid tiling in case we want to always have the cell size to be 1 by 1. But if we want to be able to modify it, we need to drag the multiply output to another multiply node, and we are going to multiply this by the size, so the vector 1 by 1 right now, but we can use it to multiply the size output of this previous multiplication. So now we can modify the size of each cell of our grid. So we're going to drag it to the tiling of the grid. I just want to point out that we are multiplying this value by the size, but obviously if we set the size to be 2 by 2 here, we are going to get more cells. So let's select the size and set it to be 2 by 2. We're going to increase the number of cells, but in our grid component, we would need to set it to be 0.5 to achieve more granular grid. So we could use a divide node here, but it is more performant if we use multiplication operations, since this shader will run this code very often. So that's why we are accounting for the performance using the multiplication node. We are going to set the size back to 1 by 1. Okay, so we have our tiling. Now we need to use the thickness parameter from our blackboard. Let's drag it. And since I have told you that we need to have the value around 1, we are going to use the 1 minus node to subtract the thickness from value 1. And now we can drag the result as the size of our grid. So this will be the size of the cells. And we are going to, thanks to that, be able to modify the value or the size of the edges or the lines of our grid. We could, of course, add one more parameter for the offset if you need to modify it. Now let's go to the fragment shader, and instead of directly dragging this result of 1 minus to the base color, we are going to drag this to the multiply node, and we are going to multiply this by the color. So let's drag the color from our blackboard, and let's multiply this lines by the color. And now we're going to drag the result of this multiplication to the base color. So if we modify the color, we are going to modify the color of the lines of our grid. Okay, so this is it for this shader. Let's save this and let's go back to our scene. In case you want to learn more about shaders, check out the Unity Shader Bible by 𝗏𝗃𝗃. It should help you out. Now, the result is that we are seeing the grid that contains 10 by 10 cells. If you want to modify it, we can go to the material in the projects tab and we can select the thickness and modify the thickness. We can change the color here and we can also change the size. If we set it to be 2 by 2, we are going to obviously have more cells. So to apply this to our grid component, we would need to select it and we are going to select the grid parent, and we would need to set the size to be 0.5 to account for the more granular grid. That's why I have mentioned that we are multiplying in the shader, but in the grid cell size we would need to set the half of the size to adjust it. We are going to leave those values as 1 and we are going to change the material size to be 1 by 1, since this is the size of the prefabs that I have prepared for the later part of this tutorial. Now let's make sure that we drag our plane to the grid parent, and let's make sure that both grid and plane are at position 0, 0, 0, and let's press play. Great, so now we have our grid visualization and we can move our cell preview or cell prefab around those cells, and we see that it moves just like we would want it to, so the grid representation is valid. I just want to point out that thanks to creating a grid parent object and putting the plane and the grid as the child objects, we can easily move it, and you will see that we can still adjust our placement of the cell representation to the grids represented by our shader, so everything is working. If I reset the position of our grid parent, I can also scale the plane. If I scale it by 1.5, we can experience a problem with selecting the cell, so we need to adjust the plane position, so just give it an offset. So on the position we are going to give the 0.5 and 0.5, and now again our cell representation matches what we have selected on our grid, and we can still select the cells that are outside of the grass plane but that are represented by our grid visualization plane. Great! In the next video we are going to start placing objects on our grid. See you there!